Find the inverse function of f of x equals to 5 minus 2 e to the x. Solution. Let me call f of x as y. I just like it. It sounds faster to say. Equals to 5 minus 2 e to the x. When they ask us to find the inverse function, which is, by the way, f minus 1. Remember, minus 1 does not mean 1 over f. That notation is reserved for the inverse functions. That means they want me to solve for the input. They want me to write down x equals what? What input gave me the output? Thus, we just need to solve this exponential equation. To solve exponential equation, EQN is equation. I usually teach the strategy that the idea is to isolate the exponential function. Thus, I will write down that y minus 5 equals to negative 2 e to the x. I want to keep isolating it, so I will divide by negative 2 both sides. Y minus 5 divided by negative 2 equals to e to the x. Now the exponential function is completely isolated, and I can apply logarithm to both sides. I will apply natural log to the left and to the right of this equation. So it's going to be natural log of y minus 5 divided by negative 2 equals to natural log of e to the x based on the properties of logarithm and exponential functions. ln undoes exponential function e to the x, and the answer is just x. So we have the solution. X equals to natural log of y minus 5 divided by negative 2. The last step is to write down the function in terms of x. It's not actually always necessary, but if the problem asks you to write down inverse of x, that means I cannot write down ln y minus 5 over negative 2, right? Because it all depends on y. Thus, I will change y to x, basically renaming the input and the output. And I will explain it in a second again. It is a little bit awkward to see negative 2 in the denominator, so let me rewrite the inverse of x as a natural log 5 minus x divided by 2. That is the answer of the question. Let's find the inverse function in terms of x, negative 1 over here. Let's sketch the graph. Here's the graph. You can grab your calculator, or maybe you're good enough, you had enough experience to graph everything without the graphing calculator. But usually you're not required to do that. Let's sketch y equals, the original function was 5 minus 2 to the x. This function looks like so. Now, to sketch the inverse function, you need to draw the line called y equals to x, which is like 45 degrees over here. Let me use a light color, like so. Y equals to x will be used as a mirror, which we use to reflect graphs. So y equals to x. And that actually kind of gives you intuition. Why did we switch in this step between x and y? Because when you use inverse functions, input becomes output and output becomes input. So here's my beautiful function, and we're using it as a mirror, reflecting the old function to get a new function, which will be the inverse. Well, it will look like so. This is the point of reflection when they meet, and it will be looking like so. Imagine a mirror and now reflect the parts. I see it like this. This part is curvy, it's concave down, so this part also should be curvy if you use y equals to x as a mirror. This part over here is more line looking, so this part over here also should be line looking, like so. You can even check that these functions actually have horizontal and vertical asymptotes. The original function has an HA horizontal asymptote at y equals to 5. Check the limit as x approaches minus infinity of the original function, f of x. It gives you 5. That indicates a horizontal asymptote. Thus, the inverse function should have a vertical asymptote, because remember the reflection idea? So the vertical asymptote here is x equals to 5, which is true. Look, when the inverse function does not exist. It does not exist when ln is taken at 0. That means x equals to 5 gives us some kind of discontinuity, and if you check, it is indeed a vertical asymptote.